Well, hi, good morning, and thank you so much for joining me here in my shop on September 7th. And today, what I'm going to be looking at is another step along the way in the alignment process. And in this case, I need to get an S-curve on my oscilloscope there, and then use the S-curve to make the adjustments that are required. So let's take a look at the instructions to start off with. Okay, so I've more or less completed this part of the alignment process. Some of these I did not do because I didn't see any reason to do them. We're down to this step number 4 here. So we're still feeding in a signal generator. Frequency I'm going to be doing, it says 92, I'm going to have to do it at 100 megahertz. I don't have a choice. So the dial setting will be 100, and let's see, oscilloscope to point AFC on AM FMX PW board through low capacity high impedance probe. Okay, well I think I have scope probes that would meet that requirement. What are we adjusting? Transformer 205 primary and secondary. Adjust primary for maximum symmetrical response of S-curve. 10.7 megahertz marker centered. Adjust secondary for optimum straightness. Optimum straightness in the S-curve. Shouldn't it be optimum S-ness? Okay, so we got to find the spot. I already know where the spot is. Point AFC on AM FM PW. There's a hint up here. The hint is right here. It says right here. AFC yellow lead coming out of the board, lined up pretty directly with this one transformer here. Okay, so I'll show you on the radio where that is. What else do we need to do here? Basically, just go at it, I think is really the way to do it. Good. Okay, so we're going to be using this signal generator back here. It's actually called a signal simulator. And the only shortfall of this is a great device. The only shortfall of this guy is he's stuck on one frequency, 100 megahertz. You can't move it around. Well, you can move it around a little wee bit, plus and minus a couple megahertz, but not much. This is quite precise. When I turn this to aim right up in the middle here, where it says 100 megacycles, that's exactly where it is. Very good. Now, they said there was a yellow wire coming out of this board. Can you spot it? In relation to this? Yeah, it's a little obvious. It's right here, right here. And if we follow that wire around to the back, here it is here, comes around and is soldered to this terminal. The 4 terminals, terminal number 3, the way I numbered it. That's the AFC point. Very good. Now, I gotta get myself a high, low capacitance, high impedance probe. So I'm going to grab this one here, which I think qualifies. Wait a minute, the tip is missing. Whoops. I have another one of those. Probably any of my scope leads would serve the purpose. Where's the other scope lead here? Okay, so I've misplaced the one I was after. Just a sec here. I'm pretty sure we can use this one too. Does it say anywhere on it? Sometimes the ratings of these are written right on them. No. Rome Corporation. Never noticed that before. CBXHW. Never noticed those markings. I don't use these very often. It's an original Tektronix lead. So, okay, if we need a better lead than the one I'm going to use, this one will do. I'll just find the cap for it. So we'll put this in here. Look at that, I already have one in there. Hey, I'm ahead of myself here this morning. There we are. So this has a times 10 switch on it. So if I put it on times 10, I'm pretty sure the impedance of this goes much higher. So we'll use this. Stick it on here. And we'll stick it on right away. Instead, we'll get this radio operating with the signal generator. Then when I make the connection, we can tell if the connection is interfering with things or not. My scope, signal generator output. This is a properly terminated output lead. I'm going to stick it on the antenna here. Now, my experience in the last short while with this signal generator is it puts out a strong signal that cannot be reduced to zero, which kind of raises the question, just how weak can you make it, or is it always too strong for some of the stuff we're doing? The signal level is very important in doing alignment work. Excuse me, you want the least signal level going in that you can get away with. That controls this little one here. Okay, so I'm going to set it about the middle right now to start. Excuse me. And I think we're ready to go. The radio's tuned roughly to 1,000,000 right now. Perhaps it's right there. Let's turn it down. Okay, power on. 119 volts. Volume up. There it is right there. So we're listening to the signal generator. Signal generator is operating in stereo right now. The stereo light's not on here. Stereo light's on now. And you can hear the change in the sound. I'm not sure that's a good thing. Right now we're feeding stereo right, but I hear it out of both channels. The alignment work we're going to do right now may improve the channel separation. Okay, let's put the scope on. Okay, ground it. And it's set to times 10. I don't think it's doing anything on the radio. Click it right on. Okay, Mr. Scopy. Oh, it's almost as sensitive as it goes. There we are. I don't think I'm doing this properly at all right now. Let's just continue though. I'm looking for an S-curve. I don't see how I can generate an S-curve from this without some more things happening. Yeah, that's not really what we want to see here. Okay, so I'm going to stop and ponder the situation here, because I think there's a big element missing in the whole deal here. Okay, so one of the things I didn't have set right was I didn't have this on sweep. So now this is on sweep. That produces a 60 cycle variation in the output frequency. The 100 megahertz is going back and forth. Got my scope triggering on 60 cycles, so it produces a stable display. But as you can see, I don't think that qualifies as an S-curve. Here's a better look at it. So if I'm close, what could be wrong now? Sweep speed a little low? No, not helping. That's quite the look, isn't it? Now, could it be overload from my signal generator? So I'm going to reduce the input signal here at the antenna just really crudely by taking one wire off. Take the other wire off. Okay, now there's no signal. What is that on the scope? What's this sound like? Oh, it's still picking it up. Yeah. Well, so you know, I've disconnected the cable here. Here's the ends of it. And there's still enough signal floating around in here to get into this radio. Hopefully it's going in the right place, like in through the antenna, and not soaking into the circuits here in the wrong place. And what is that display? A wide bar, narrow bar, wide bar, narrow bar, wide bar. Maybe if I tune the radio. I may not have the radio tuned properly here. Well, that's just far, far, far away from any S-curve. I would guess that's tuned about right there. Or is there an S-curve in there? And my scope is maximum sensitivity. My scope lead no good. Scope lead is dragging this down. I have to try a different scope lead here. Okay, let's try a different lead. These are real Tektronix scope leads, not the other kind I have. This has a special little deal on it. Alright, plug this in, it automatically switches the scope input sensitivity. It says times 10 on it, and there's no switch. This is always a times 10, and this will automatically change the setting on it, and you can't quite see it there. Watch this when I plug this in. I mean, if you have a Tektronix scope or you've used one, you know this, but check this out. So, see how it's a little hard to see. See how number 5 is lit up here? Just by putting this lead in. It's switched. Just by putting that lead in. So that's accounting for the times 10 deal. Okay, let's check it. Yeah, it's working. Okay, I'm going to hook it up to the radio here. Let me take the other one off. Turn the volume up so we can hear any effect. If there is one. Okay, that's ground. Attaching it now. Nothing happened. And we get pretty much the same image there. Except I can't make the scope any more sensitive. Yeah, but didn't affect the sound. Got basically the same image, but weaker with this scope probe. This doesn't look anything like an S-curve. So where am I going wrong? Let's tune the radio again. No, they're not going to get. It's just not. It's nowhere near what it's supposed to be. Don't you have to detect these signals? Don't you need a diode in there somewhere to make this work? Okay, before we go any further, let's just see if transformer 205, that's supposed to be adjusted, is even adjustable. Maybe the slug is stuck. So I'm guessing this is the right size. This is TR205. There's one slug there. Could maybe only one slug. Going down. I think one very large slug. That's what I think it is. Okay, so I'm going to come out the top again so I got an idea where I am with it. Okay, back in. Now I'll try turning it. Yeah, it moves. Yeah, so that's the one that's supposed to be adjusted. That's good. Okay. Still don't have the right kind of display though. Jeepers creepers. How come? Well, there's something a little more interesting on the oscilloscope, but I'm not quite there yet. So I started reading the instructions for the signal simulator here, and what it says is something I have never done, and I guess maybe I've never fully utilized this signal generator. The composite signal audio output line is supposed to be hooked up as the sweep on the scope, which it is right now. That goes up to the scope. It's causing the sweep here. Hasn't turned it into a beautiful S-curve, but there's some SE sort of stuff in there. it could be on my way to, oh my God, no, going through a whole maintenance routine with this guy, making sure it's working properly. I'm using it now in a way I've never used it before. Never paid attention to what comes out of here. This can also be used to pump signals right into the radio audio side of it, and eventually I'll need this also to do that. I wonder what's on this. Well, it's right on my scope there. I just flip a lead, just flip a control. That's what's on there. What is that? Composite audio signal. I have it connected across a resistor here that I put on there some time ago, and that resistor is a something black, so it's a very small resistor. Not making any difference at all. I don't know why I put it on there. Long time ago. The unit's set to sweep. Take it off sweep. These are different audio signals that are provided here. This is the sweep setting. I guess basically you're using the same cable for the audio signals and for a sweep signal when you're in this mode. My scope, we set back to sweep. Yeah, so I'm using line here. I'm pretty sure this is. Well, maybe it isn't. Maybe it should be triggering on. Well, it's not going to trigger on anything here because I have it on XY. Well, I got to stop and read in detail the instructions for that machine because something's not working out here. Okay, so I've read the manual for the device, and I have the instructions for working on the receiver, and the two of them don't quite jive. There's lots of different combinations of everything. There's different test equipment, there's different receivers. So it's up to me to figure out how to get that piece of test equipment to help with this particular receiver. One of the interesting things in the manual for that guy is it says it's very, very useful for figuring out if something needs service. But if it needs service, then you should follow the manufacturer's instructions exactly, including the equipment that they specify in their instructions. And then it goes on to explain how to go ahead and use this on any receiver. So it's a kind of a weasel word there, or a weasel sentence. And that sends a warning to me, a little bit of a warning that it may be very difficult to get this to work. It really shouldn't. I have succeeded in getting S-curves on my scope, but it's always been quite a struggle. So now there's always the chance too that this device isn't working right. So I'm going to take a look at that a little bit. Like right now on the scope you see a sine wave going by. That's the RF sweep that's appearing. What we're looking at the end of this cable, which is this composite signal output. With the machine set in RF sweep mode, it puts 60 cycles out of here. Well, it seems like if you're sweeping at 60 cycles and then you're using this 60 cycles to drive the horizontal, it should be just fine. So we flip this to mono, audio mono, and now it's producing in this case, 1,000 hertz signal. We can get it to look more like a sine wave. And I don't know if my scope is going to trigger here. Let's see. Okay, there we are. Nice sine wave. That's at 1,000 hertz supposedly. And this is 400 to 400 there. 1,000. 5,000. You can also get a 19 kilohertz. Let's see if that shows up. Well, I'm not sure I see 19 kilohertz in that. Well, maybe there it is. Very hard to see. Very, very small signal. Lots of RF noise around it, but there's something there. I don't care about these higher signals right now. Oh, did you see that? Oh, so the switch wasn't set quite right. So that's 19. This should be double. 38, lots of signal now. Looks like a hum in there or something. A 67 kilohertz signal. They're all here, 72. And that's for external input. So everything's working here. Right down to 400 cycles. Looks just great. And we switch this to audio left. Look at that. That's exactly what you're supposed to see, I believe. Audio right. These are, I believe, 180 degrees out of phase, but because of the triggering, the scope ends up displaying them in the same way. They look the same. Internal test. There's something interesting I read. There's a setting here called internal test, which is a way to present a known signal to the device internally and to double check its calibration. It's one of the critical calibration things. So I got to read a little more about that. Well, it seems to be producing the correct outputs. So we set this back to sweep. The 60 cycle sweep here, we set this to utilize it. The 60 cycles is now doing this. Now there's no blanking in this device at all, so it's sweeping back and forth. So it's really painting this weird image twice, and probably painting it a little bit phase shift. There's a phase shift between the two versions of it. What's with all that staticky stuff in there? What's all that supposed to be? Looks terrible on the camera here. Why all that snow? Now, what we're looking at, I don't want to look there. As I flip this over to XY, it automatically uses this input as the sweep and puts this input on the screen. So we're looking at our X input here. Y input, Y input, Y input, vertical input. Fiddling around over here. Did by some chance did I grab the wrong spot? Now that's no input. No, this is the spot, I'm sure of it. Turn the volume up a little bit on the radio. Tune the radio a bit. Trying to get a strong sense of where center tuning is, right there. Right in there. How about why? Am I supposed to use this? This? It's supposed to be a really nice looking single S-curve. I still think there needs to be some kind of detection going on here, but it doesn't mention it anywhere. It's pretty easy to experiment here with a detector. Let me just grab a diode. Oh my gosh, here's one right here. And I'm just gonna stick a diode in the scope probe, basically. Oh, is that really a diode? Didn't seem to have any diodic effect. Maybe it's not a diode. Well, it sure is. It's a really cool one. I'll show it to you, so you know what I'm muttering about. That's pretty cool. Has the diode symbol right on it. Didn't seem to do any diodic behavior. Is that such a word? Diodic. I have some more. I have some more. I have many more. Let's grab one here. Like a signal type diode would be best, probably. Haven't there any loose ones laying around? Okay. Oh, those, wow. Here's like the crystal in my crystal radio when I was a little kid. Okay, not sure it's going to make any difference, but let's give it a try. There we are. Got to watch the scope here. Eyes upon the scope. Diode contact. Oh. Bad contact. There we are. It's, you know, it's a little different, but it's not at all what we're looking for. So I'm shooting in the dark here. The next question would be, well, is this because the radio is way out of alignment? Is this what it is? And if I twiddle things, it'll turn into an S-curve. Wow, that's hard to believe. That's really hard to believe. Oh my gosh. I'm stuck here. So one of the things I could do is just forget the instructions that come with the receiver and sort of go at this in a more, I don't know what to call it, freehand way. That just doesn't seem like the best idea, but I'm going to have to try that. That's really challenging because I'm going to have to read the instructions for the generator and read the general instructions for how to connect it to a radio generally. And then somehow I have to turn that into specific instructions for this machine. No, I shouldn't have to do that. It must be something wrong with how I have this operating. There has to be something wrong. Okay, here's something very significant. Now I have the output of the signal generator connected only with one wire to half the FM antenna. I'm going to connect the other wire to the other antenna screw. Ooh, now that made a huge difference in the way the scope looks. Let me just turn the brightness down here a little bit. Very hard to get a scope to show on a camera like this. What do we got now? Let me tune a little bit. Now, is that an S-curve in there? I turned down the volume so we don't listen to this anymore. Well, we got a few things to adjust here. Make the vertical more sensitive. I can't because of the probe I'm using. That's as big as it's going to get vertically. Ay. Well, it's enough to see something. Next thing is things like deviation width setting. Let me flip cameras here. There's not much to see on the scope, so I think if I just, you can see what I'm up to, kind of make sense of what's happening here. What am I up to? Okay, so we're going to fool around with this deviation control. Just changes the degree of the sweep. It's also changing the deviation in the FM signal being sent to the radio. What if we tune? Oh. I stepped on the camera wire. Okay. What was I going to do? So we're going to try to utilize this. Now, so what is sweeping on what's causing the scope sweep now is a 400 cycle signal you're hearing. Is that an S-curve? Tune the radio a bit. Well, yeah, I wouldn't really call that an S-curve, and there's something funny right there. You just kind of shooting in the dark here, but that's okay. It's okay. You know. Try a higher frequency, get the same result because everything's up. Oh, now that's interesting. We're at 5. That's a 5 kilohertz signal, and it's not being handled the same as the lower frequencies. Can't go any higher with this guy using its internal signals. Is that an S-curve? Let me just make it a little bigger here. How do I turn up the RF gain, the RF power here? Oh my gosh, look at that. What happened there? The instructions say have this thing running full blast. Okay, that may have changed the frequency. I'll tune the radio a bit. We're getting closer to something that looks a little like an S-curve. Sort of. I remember this guy has no blanking. So the sweep it's like a circle laid flat, right? The sweep. So it's slow, fast, slow, fast, slow, fast, going like that. That's why it's brighter here and brighter here. It's spending more time at the ends. It's sweeping in one direction and then sweeping back, getting a completely different result here. I think I'm really close to getting an S-curve. What else could it be? Okay, back to the deviation. No, the deviation isn't gonna change the shape. That's using 19 kilohertz. Interesting. Oh my gosh, that's using 38 kilohertz. Oh, that's a really exciting shape there. That's the coolest thing I've ever gotten on a scope. Somebody dig up Mr. Lissajou and show him this. I think he'd like it. And this is 67 kilohertz. For some reason, here's 72. These signals mean nothing. I'm just playing around here, but that's kind of neat. I like to have that on my scope when I bring people in here to look at my shop. Look at that. Of course, if they ask me what it is, I'm in big trouble at that point. So they're all doing similar things. It's just the higher frequency is being handled differently by the receiver circuits, especially the super high frequencies there. Exactly why they even appear on my scope that way, I don't know. You'd think the receiver somehow would limit itself to, 15 kilohertz or lower, but I don't know. I don't know what's happening. What if I make the adjustment and see what goes on? I'm going to make it in just a little bit, so I'm putting the tool into that transformer you saw earlier. I'm going to turn it a little bit. Well, not much happening. Okay, leave that alone. I'm sure I'm off target here, but I don't know why. Back to the sweep. See, even the sweep actually gives kind of a similar shape. It's just really squashed. So you're coordinating the sweep speed with the speed of the signal, the frequency of the signal you're sending through the radio. Yeah, I don't know. I gotta find another place to connect the oscilloscope. I think that's the name of the game. Or figure out why they're suggesting what they call the AFC. Well, what is that actually in the circuit? Okay, if we look at the circuit diagram here, let me just move my camera out of the way. First of all, the AM detector. I believe this diode is the AM detector coming out of the AM IF string through here. Well, that would leave this being the FM side of things. Look, it says 10.7 right here. So this is definitely the FM coming through here. FM-IF comes out, goes through this transistor, comes into this very special transformer here. The other side of this transformer, look, it still says 10.7 there, has these two diodes pointing in different directions. So this is the detector. There's a capacitor right in there that I changed. This electrolytic capacitor right here. You can tell just by looking at it, there's some balance to this thing, the way they've designed it. Of course, it has to be. And out of here, where is the out? So look at this, look at this. There's a wire coming off the board, AFC. And you know what? If I were to pick a spot, this would be the spot I would pick to stick my probe. Although personally, and not knowing for sure whether this would, you know, wreck the radio, like throw it all off, I don't know. But I guess because they are specifying it, we can assume this is a fairly low impedance test point. It did warn about the probe having to be high impedance and low capacitance. So it's definitely a sensitive point. In fact, everywhere you go it's sensitive. Until you get into the audio range, really. And since the IF here is quite high, it's 10.7, you know, people send signals around the world at 10.7 megahertz. The IF for the AM is only 455 kilohertz. And quite a difference. So all these issues come to the fore when you're trying to do this work. Are your probes good? Is everything good? Is anything good? Is anything going on? So if that's the spot, well, I don't have another spot. I don't have another spot. I mean, I could go down here, but they aren't recommending it anywhere. They're saying here. I'm agreeing with them, for crying out loud. So now we're left with a really schmozzly situation. My signal generator doesn't work. Doubt that. The receiver is so out of whack. It looks the way it looks. I doubt that. We're listening to radio stations on it. It must be working essentially correctly. I've misread the instructions. Okay, that's possible. I've misread or overlooked some key part of the instructions. Wow. What to do here? Something isn't set right. And the main thing I should do is stop, drink some coffee, and go visit my cats for a while. And then look at this again, because I really hit a hard dead end here with what to do. Well, I may have found something. In the instructions, much higher in the document, it says turn on the AFC. So I've been doing this with the AFC switch set off. That strikes me as bad news. Let's turn it on, see what happens here. Ooh, that made a big difference. Ooh, hot diggity dog. You know, the instructions, they refer to the S-curve, and then they say make the adjustment of the transformer secondary to achieve straightness. Straightness. S-curve. Straightness. How do those two things even go together? Now I'll fiddle around with some adjustments here and see what we can get going here. First of all, I'm not on RF sweep. I'm on RF sweep, setting the deviation quite low. You know what, I'm gonna shrink it this way. Set the deviation. It's supposed to be up around here, like that. Okay, got some curvy thing happening there. Next thing would be 19 kilohertz switched off. Tune the radio. Tune the radio. Now there's an S-curve if I've ever seen one. Increase the RF output. Oh, it's maxed. Okay, decrease the RF output. Okay, we're at the minimum RF output, and tune the radio again. It's just not very happy with this at all, is it? So I'm going to set it to audio frequency of 5 kilohertz. Deviation down a little bit. Scope a little wider. Just ain't no S-curve happening here. This, I'm going to guess, like this curve is really the trace out and the trace back being affected differently from, you know, capacitance or some kind of impedance or reactance in the circuit that's causing this. Maybe even in the probe. So this side shows no RF, but this side is fat with RF all over it. I have no idea what that means. Okay. I think I'm getting closer. Closer and closer. Now those are two stereo signals, 1000 hertz, 400 hertz. Whoops. Yeah, it takes time for my signal generator to react when you make these changes. That's 19 kilohertz, doesn't show anything. Okay. Well, I'm just goofing around here at this point. Well, hey, actually I've been goofing around here the whole time, haven't I? Well, I'm going to have to stop at this point. That's disappointing. My goal today was to at least get an S-curve on there. I got a lousy O-curve. Oh, okay. Well, you know, I'll just keep working away at it here, I guess. Well, tomorrow, because it's today's probably the last nice, warm, sunny day for a while. So I'm gonna spend it outside. Thanks a lot for watching, and sorry I didn't get to what I need to get to, but hey, this is a par for my course anyway. See ya.